Hey Algebra 2, in this video I'm going to be teaching you about logarithmic functions. We're going to focus on graphing. So before we talk about graphing, we want to talk about parent functions. So it's important that you remember that logs and exponentials are inverses. This is important because it's going to help you determine your key points. So parent functions are going to work kind of similar. So for an exponential, we might have y equals 4 to the power of x. And your key points for this parent right, your x values are going to be -1, 0, 1. And you substitute it in, right? So 4 to the negative first is 1/4. 4 to the 0 power is 1. 4 to the first power is 4. So for the inverse here would be y equals log base 4 to the power of x. So your key points are the inverse, which remember means we're going to switch the x and the y values. So now it'll be 1/4, 1, 4, and the y values will be -1, 0, 1. So if you remember, like when you go to graph a logarithm, remember that you're switching the x and the y of whatever the base is. That'll be very helpful. So this is, I don't even know, we've done so many functions in Algebra 2. This is a new one. We're going to do transformations of logs. And we're going to break it down piece by piece. So generalized equation will be y equals a times log of the base, or log base of b parentheses x minus h close parentheses plus k. And this is going to be incredibly similar. All the letters affect the function the same way they have been. So a, because it's not with the x, it's on the outside, is going to be a vertical dilation. It's being multiplied. If a is negative, remember, negative is not a negative dilation, and negative is a reflection over the x-axis. Okay, so that is a. Now, your base is going to be really important. Because your base is going to give you your key points. Of your parent function, and then you'll be able to determine what your new points are. Alright, B is a horizontal dilation because it's multiplying and it's inside of the x values. If it's negative, it's a reflection over the y-axis. So that's B. Then we have H. H is going to translate your function left or right. Remember, it goes the opposite direction. So if it's plus h, that means we're going to the left. If it's minus h, we're going to the right. And finally, we have our k value. And k is going to translate up or down. Now, if you remember, our exponential functions have a horizontal asymptote, and the horizontal asymptote, right, is affected by vertical translations. The inverse, because we switch the x of y, is now going to have a vertical asymptote. So, and that is going to be moved based on a horizontal translation. A horizontal translation will move the asymptote. So the equation will always be x equals whatever h is. Alright, so let's do an example. Alright, so an example would be, let's graph y equals 4 times log base 3 of x minus 1 plus 2. Remember, you must list transformations, make a table like I do. We've been doing this for every single function, nothing's changed. And then graph and label the asymptote. So if you want to get full credit, you have to do all of these things. Alright, so let's do the transformations first. So for your transformations, actually you should probably do the parent too. So for the parent, our parent is going to be just log base 3 of x, right? Should do y equals, sorry. It is an equation after all. Okay, transformations. So we have a 4 on the outside, it's being multiplied, so it's a vertical dilation. By 4. Inside the parentheses, we have a minus 1, so that means we're going to translate right 1. And then we have a plus 2, so that means we're going to be going up 2. So now for the table, remember you want to think of the inverse. Right, so we want to think of the y equals 3 to the power of x for the table. So when I make my table, right, the x and the y's are different, so this is now going to be negative 1, 0, 1, and this will be 1/3, 1, and 3. And then I'm going to expand my table based on my transformations. and solve for my new transformed points. So vertical dilation by 4 affects my y values. Translating right 1 will be x plus 1, and up 2, we add 2 to the y. So 4 times negative 1 plus 2, 4 times 0 plus 2, 4 times 1 plus 2. Same thing over here, so 1/3 plus 1, so 4/3, or you could write it as a decimal if you'd like. It's going to be 1.3 repeating. 1 plus 1, and 3 plus 1. So this is all based off the parent. Now we're going to take these and we're going to graph them. So I'm going to make a coordinate plane. I'm going to go up to +6 and down to -3. And for my x values, I'm going to do -3 to 6 as well. Alright, so now that I have my coordinate plane, I recommend graphing your asymptote first. So remember, your asymptote is based off any horizontal translations, because at the parent it's going to be at 0. So because we're going right 1, that's going to be the equation of our vertical asymptote, x equals 1. And don't forget the equation. And then we're going to plot our key points. So 1.33333, -2. 2, 2. Right, 1, 2. Careful to make sure you count from the y-axis and not your asymptote. I think I almost did. And then 4, 6. 1, 2, 3, 4, 6. So it's going to be getting really close to the asymptote, but never going through, and then curving up. And that's it. So I could ask for the domain, and I could ask for the range. We can pretend for a sec that those are follow-up questions. So the domain of this function, right? X values that exist, the leftmost, it's going to go really close to 1, but never actually intersect. So it's soft bracket 1, and it's going to keep going to the right infinitely. And the range is going to go down infinitely and up infinitely. We talked about this in the last chapter, right? The domain and range is the inverse of what it would be for an exponential. So that's graphing. Make sure you list your transformations. Make sure you use the right vocab. Make a table of the parent, extend it, apply your transformations, graph.